Welcome back, Python family, to the Python Made Easy series. Today's session is all about exceptions. We will explore Python exceptions. We will learn what they are, why and how they are used. We'll see implementation examples, and we'll get a few tips along the way. Let's jump in. What are Python exceptions? Exceptions are events that can modify the flow of a computer program. They are triggered automatically when errors occur. They can also be triggered manually by our code, and we have examples of that. Exceptions can be raised in any part of the program. Sometimes errors should cause a program to terminate, but other times you want to recover from them and continue to process your code. That's what this class is all about. There are really 4 different statements that process exceptions: the try except, and the try finally, the raise, the assert, and the with as. We've already seen the with as when we talk about opening files or reading and writing to files. Note, very important, all errors are exceptions, but not all exceptions are errors. When you do a Control-C at the Python Interactive, this raises a system exit. This is a signal and not an error. So we'll keep that in mind as we go from here. What are the reasons we'd want to use exceptions in our code? There are several good ones, but here are just a few. To enable us to break out of a section of code and then respond to the exception in a way that's useful to our program. They allow us to jump to certain sections of code based on conditions. They can be seen as a sort of go-to command. We don't have that in Python, in the Python language, but these can be seen as taking the place of that or playing in that space. This slide complements the slide we just came from. What purpose do exceptions serve? Well, here are a few good ones. Error handling, to catch and respond to errors that arise in code. For event notification, this is a signal of a valid condition. Termination actions, this ensures that specific operations will be performed if an exception occurs or not, such as the famous one is closing a file. Control flow, exceptions can be used to control the flow of our programs. An example is to break out of multiple loops. And then there's some special case handling. These are for conditions that rarely occur. Okay, so we'll look at the code. I have 2 examples here, example number 1 and example number 2. Example number 1 has no try except to trap and handle the exception. Example number 2 does. So what is the difference? So I have a function defined as add me. It takes a parameter y, x equals 5, and then return x plus y. So we pass the argument hi, we pass a string when clearly we're expecting an integer because we couldn't add an integer to a string. It returns exception has occurred, type error, unsupported operand, type S for plus, int, and string, program terminates. All right, so immediately our program is going to terminate once it tries to reconcile and process this code. Now, in the second one, we're going to use a try except block. Okay, so we try, same thing. We're calling our same function, add me. We're passing hi. We're trying to do the same silly thing, which is to concatenate or add an integer to a string. Then we have in our error handler except type error, which should catch and recover this type error that comes through. It should print wrong type used, I keep going underneath that. And then further, when we jump out of the block, we now can print everything that comes after it, or we can now execute the rest of our program in essence, right? So print program doesn't stop. So if you see the output on the right hand side, that's exactly what happens. We print wrong type used, we print I keep going, and then finally the program does keep going outside of the block. So that's the advantage. That's the reason why we want to use the try except. It traps it, it handles it, and it allows our program to keep on executing. Now in our first try except block that we saw in the previous slide, we used one of the built-in types, which was the type error. We'll see here that we can use any number of different types with except, and we can also use a catch-all by including no type. So let's go through these. So we have 6 different examples, and then the 7th is the catch-all. So we have a try except block, and this illustrates also that we can use multiple except branches, and Python will stop at the first one it sees that fits the bill. If name and type fit the bill and it sees name first, it'll use a name error to trap. So let's see the first one. The first one, we have a list 1, 2, and 3, and then we have something called list 1, but it looks like we're creating a dictionary. So then we try to append to list 1. Of course, you can't do that to a dictionary. We pass list 0 there to it. And what does it do? It gives us an attribute error, right? So I tried to put a second print statement underneath to tell you which one won in this time. And in this case, it goes way down to the 4th. Not name, not syntax, not type, but it's an attribute error that this fails on. So the second one, number 2, down below, we have hello equals hello. So a string hello with 5 characters in it. And we're trying to print the 7th index or the 7th position, and it doesn't have that, right? So it should give us a index error, right? Because we're beyond index. So instead of getting the default error, we're getting one that we create. So it'll say index error, and it'll print this one wins underneath it as well. The third one is a type error. So we have hi equals hi, x equals 2, and we're trying to do exactly the same thing we did in the previous slide, which is to concatenate or add a string to an integer. And that fails with our print error, type error. This one wins, and then it'll go on executing. The fourth one is a name error. We have 1 equals string 1, and then we try to print 1 capital. Can't find that name, so name error. This one wins. 5 is a syntax error. Eval A equals B. Well, this isn't JavaScript, so we can't use the 3 equal signs there. So this will fail on a syntax error. Note, it's very hard to trap a syntax error. You can only catch syntax errors when Python is trying to parse something. So if you purposely try to use this, there are 3 situations that you'll get it during using the exec, the eval, and the import statements. In the 6th one is a key error. So now we're dealing with dictionaries, keys, and values. So dict2, we have 2 elements in our dictionary, and then we try to print 3, which doesn't exist. So we'll throw a key error there, and ours says key error, and this one wins. Now 7, like I mentioned before, this isn't specific. You might want to do this in some cases. It'll catch any error and return, in our case, all other errors. So we have the same thing. This would be a key error. If we had that, it would go to key. If key was before this general catch-all except, it would go to key first. In this particular case, we only have the generic catch-all except with no specific built-in type. So it's going to default to that print all other errors. And if we had code underneath this or after this particular try except block, it would continue with the rest of our program. There are many other error types. These are just a few of the more notable ones. There's also an else branch in the try except block that some people may not use. But let's talk about the benefits of this, and you can be the judge. The benefits of using the else branch is it's very clear to know if there was an error and if it was trapped, or if there wasn't an error. The only way the else branch is taken is if there was no error trapped. It's not good enough to have a print statement immediately following or on the outside of our try except block, because that's always going to run anyway. So it's not an indicator of what actually happened inside the try except. So else makes that completely unambiguous. And you see our examples here. We have try y equals 1/0, and then we have a 0 division error because that's what's happening here. And of course that's what traps, and it prints out the handler you're trying to divide by 0, and the else branch will not get printed out here. Now in this case, if we had code outside of that, it would print anyway, right? It would print, it would go right on. Whether there's an error or not, any code outside of the try except would print. Now in the second example, we have try y equals 1 divided by 1. Well, it's not going to fail on the 0 division error because it doesn't apply, that it is not an error. So in this case, it goes right on to print, else branch has been reached, no error trapped. And then if we had code outside, it would go on to that anyway. So having the code outside doesn't help you understand what happened in the try except. We simply know that it was handled or it wasn't handled, and our program moved on. So the else branch makes that completely unambiguous for you. So we've been exploring so far try except. There's also a try finally block. The finally branch ensures that the appropriate cleanup code takes place. So in this very first example, there is no error to trap, but the finally branch will be executed no matter what. So no error, file is closed, is what gets printed out every time this code is run. Following this, the execution of the code continues with the print statement outside the try finally block, and that says keep going, all is well. So the important thing to take away is the finally always gets executed no matter what happens, error or no error. Now, in example number 2, we have a type error in the try branch. However, you see that the code in the body of the finally branch runs here too, if you look at our output that I have right here. The difference is it terminates the program after it runs and does not run what comes immediately following our try finally branch, since there was an error. It simply closes the file and terminates the program. That is the difference between these two different code examples. Hopefully that's clear. we can use what is sometimes called a unified try, except, finally block here now. We have two code examples, number 1 and number 2. So for code snippet number 1, we have a type error in the try branch right here. So that will be caught, and the handler in the except branch will execute. It'll print out type error caught. Then, as it always does, the finally branch is run, printing out its print statement. So finally always runs. Then instead of terminating in this case, the print statement after the try block is executed, and we would proceed with our program from that point on. So that probably makes a lot of sense from where we've been. The else won't run because there was an error trapped. Finally always runs, and we continue. So now, in our second example, we have a type error in the try branch. In fact, the very same one. So that will be caught, and the handler in the except branch will execute. Same as always. But in this code, we have a 0 division error in that except handler. We're trying to divide 5 by 0. So then after that, the finally branch will run as it always does, and it'll print out its print statement, finally always runs. But this time the code will propagate to the default level handler as we see the 0 division error. At that point, the program will terminate. So you see here in code number 2, error in the except branch happens before we enter the try catch block. Then we have type error was caught because there is a type error. Then we have finally always runs, and then it propagates up to the default handler. We get the division by 0 ugly error, and our program ceases. So that's the difference between these two when you want to use these try except finally blocks unified. And finally, we're always able to trigger an error manually. We can do this by using the raise keyword. The built-in raise exception statement will trigger an exception. When the exception is raised, program execution is interrupted as the interpreter searches back up the stack to find a context with an exception handler. So why might we want to raise an error? Well, a few of the purposes could be for error checking, to indicate that the situation is exceptional to the normal flow of your program, to give a user-friendly version of an error, to warn consumers if they're using your code, the code that you built, in an incorrect way. Some general guidance around raising an error. Be specific. Use the most specific exception constructor that fits your particular issue. And the message string should clearly explain what the problem is. So let's see what we have here. We have a try, raise, type error, and then we have an accept, type error. And what we get printing out here is you raise the type error. Here, we throw the raise statement a second time to then propagate the error up to the default level handler. So let's see how it's different here. Try, raise, name error, hello, accept name error. So it should print propagating to default level. But then we raise it for a second time by calling raise. And when we do that, it propagates up to the default level in this case, and we get the ugly error from Python, exception has occurred, name error, and it actually prints out hello. These are two different examples of how we can use the raise keyword in our code. Okay, Python family, thank you for watching till the end. If this class has helped you, consider helping me to continue to bring these classes to you and others. Helping is easy. Just do the following. First, subscribe to this Yogi Coder YouTube channel. Next, like this video and leave whatever comments or questions you'd like. And finally, share this video on any and all social media channels with your friends and your colleagues. And as always, this presentation and its associated code will be stored up on GitHub at the link shown in the section below. That's it for now. See you in the next one.